Every time you search for something, pause on a video, or type a message, a machine is taking notes. That data does not just sit in a folder somewhere. It becomes the raw material that teaches AI systems how to think, predict, and respond. In this video, you are going to see exactly how AI learns from your data, step by step, in plain language. Let us start with the obvious question. What counts as your data? The answer is broader than most people expect. It includes the words you type, the images you upload, the links you click, how long you hover over a piece of content, and even what you choose to skip. All of that behavior leaves a trace, and that trace is data. Companies collect this data through apps, websites, smart devices, and services you use every day. Some of it is collected with your consent through terms you agreed to. Some of it is anonymized before it ever reaches a training pipeline. Either way, the volume is enormous. We are talking about billions of data points generated every single hour across the internet. But raw data is messy. Before any AI system can learn from it, that data has to be cleaned. Cleaning means removing duplicates, correcting errors, filling in missing values, and filtering out noise. Think of it like preparing ingredients before cooking. If you put garbage into the process, you get garbage out of the model. After cleaning comes labeling. Labeling is the process of tagging data so the machine knows what it is looking at. An image of a cat gets tagged as a cat. A customer review gets tagged as positive or negative. This is often done by human workers, and it is one of the most labor-intensive parts of building any AI system. The labels are what give the model something to learn toward. Here is something most people do not think about. Computers cannot read words or look at images the way humans do. Everything has to be converted into numbers. A word becomes a vector, which is a list of numbers that represents its meaning in relation to other words. An image becomes a grid of pixel values. A piece of audio becomes a wave plotted as numbers over time. Numbers are the only language a machine actually speaks. Once data is cleaned, labeled, and converted into numbers, training can begin. The model is shown a data point and asked to make a prediction. At first, those predictions are essentially random. The model has no idea what it is doing yet. But that is expected. The goal of training is to make it better through repetition and correction. After each prediction, the model checks its answer against the correct label. If it got the prediction wrong, and it will get it wrong many times at the start, the system calculates exactly how wrong it was. This measurement is called the loss. The higher the loss, the further the model is from a correct answer. Now, here is where gradient descent comes in, and I promise this is simpler than it sounds. Imagine you are standing on a hilly landscape in the dark, and you want to find the lowest point in the valley. You take a small step in the direction that feels most downhill. Then, you check your footing and take another step. Gradient descent is that process, applied to mathematics. The model adjusts its internal settings slightly in the direction that reduces its loss one small step at a time. Those internal settings are called weights and biases. Every connection inside a neural network has a weight, which is a number that determines how much influence one piece of information has on the next. During training, these numbers are updated thousands or millions of times until the model starts making accurate predictions consistently. The model does not see each data point just once. It runs through the entire training dataset multiple times. Each full pass through the data is called an epoch. With each epoch, the model gets a little sharper, a little more accurate, a little better at generalizing what it has learned to new data it has never seen before. After training, the model is tested on a separate set of data that was held back during training. This is called the validation set. The point is to check whether the model has actually learned something useful or whether it has just memorized the training data without understanding the patterns. Memorizing training data without generalizing is called overfitting, and it is one of the most common problems in machine learning. Once a model passes validation, it gets deployed. But learning does not stop there. Real-world feedback, meaning how people actually interact with the model's outputs, becomes new training data. If users consistently correct the model, flag its answers, or ignore its suggestions, that signal feeds back into the system, and future versions of the model are retrained with that feedback included. This feedback loop is part of why AI systems seem to get smarter over time. It is not magic. It is iteration. The model keeps seeing more data, keeps getting corrected, and keeps updating its weights to reflect what works and what does not. Now, let us talk about the part that matters most to you personally: bias. If the data used to train a model reflects historical inequalities, social stereotypes, or gaps in representation, the model will learn those patterns and reproduce them. A hiring algorithm trained mostly on resumes from one demographic will tend to favor that demographic. A facial recognition system trained mostly on lighter skin tones will perform worse on darker skin tones. The model is not making a moral choice. It is reflecting exactly what it was taught. This is why the phrase "garbage in, garbage out" is taken so seriously in AI development. The people responsible for curating training data carry enormous influence over what an AI system values, what it ignores, and who it serves well versus who it fails. Data curation is not a technical afterthought. It is a design decision with real consequences. So, what can you do with this knowledge? A few practical things. First, you can be more intentional about what data you share and with whom. Second, when you interact with AI tools, you are contributing to future training data, whether or not you realize it. Third, when an AI system makes a decision that affects you, you now have the vocabulary to ask the right questions about what data trained it and who labeled that data. Understanding how AI learns from your data does not require a computer science degree. It requires a clear picture of the process, which is exactly what you just got. Data gets collected, cleaned, labeled, converted into numbers, and fed into a model that adjusts itself thousands of times until it can make reliable predictions. Then it keeps learning from real-world feedback. That is the whole cycle. If this video helped you see the process more clearly, hit the like button. It tells the algorithm that this kind of explanation is worth showing to more people, which helps the channel keep making content exactly like this. Subscribe if you want to keep building your understanding of AI without the hype or the jargon. Next week, we are going deeper into large language models specifically, covering how they are trained on text at a scale that is almost impossible to visualize, and what that scale actually means for the things they can and cannot do. That one is worth watching.